and you can take screenshots, and if you are recording, you can solve it later as well. It's up to you. These questions are designed just to make some of the concept clear, and I hope this student body that is organizing has a lot of electrical people, and I'm guessing it's mainly electrical, and some of from the other branches as well. Anyways, it's a very general session, not a highly technical one, because it's difficult to cover every technical details into a 1 hour webinar. So I'll start. And so first of all, if any technology, first we want to discuss the block diagram of EV charging. And another thing, I have referred the most of the papers that I have taken, I have cited at the end of it, so you can go through the papers in your leisure time. Okay, so block diagram of EV charging. EV charging is firstly, we break it down into 3 or 4 levels. So level 1 and 2, level 3, and another one is extra fast charging. So first of all, level 1 and 2 is basically for our 2 kilowatt to 20 kilowatt single phase or 3-phase AC supply. And that is fed into rectifiers which convert into DC, DC to DC, and then it goes through the battery and the BMS here, which is the battery management system, monitors everything and controls the part inside our EV. So this is our onboard charger, this is our charging station. And similarly, the basic difference with a level 1 and 2 with level 3 or higher levels is that the rectifiers inside the onboard chargers are not necessary here. It converts variable DC initially rather than here the AC here, and so this is the main difference, and it solves a lot of problems, and also it is mainly used for fast charging. And in the next few slides, I'll compare all the 3-4 chargers, and it will be a little bit more clearer to you. Before I go into charging, the EV charging, I just want to give you a little bit idea about how and why EV charging, and also if you have gone through the brochure, we have discussed about vehicle to grid charging, also vehicle to vehicle charging, which is the upcoming. A few of the researchers are working on it, and it's a very good field to research. So for that, a little bit into that, I have taken a problem, and I'll just show the screen, take down the problem, and then we'll move forward to it. So if anyone is confused about SOC, SOC is the state of charge, which essentially means if a 58 ampere hour is a battery, so the 90% SOC will be the 90% of this. That's the simplest way I can explain SOC. So I have given so a person has a car of a 58 ampere hour battery, which is 90% charged at that moment, and when it is disconnected from the grid due to failure of the grid. So the grid electricity was charging his battery, but due to failure, it starts to not work. So and this battery instead is used to power his household. And the household power that is needed is around a 8.2 ampere DC supply. To make things easy, this is converted into DC, although powers are not necessarily using, let's say it feeds through an inverter in the household, and that converts it to DC. So this is the current required. So let's say the power grid fails at 12:07 a.m. And so my question is, will the power still be available, or will the battery in the EV be still be able to feed the power till 6:25 when the sun rises up and the solar panel starts to supply the current to the house? This is a small question. You can solve it intuitively, or you can solve it with numerical values. Um, I'll just so it's 7:12. I'll just wait for 2 minutes and then I'll discuss, because it's a very short webinar. I don't want to take a lot of time. Just try to solve if anyone is interested. Uh, if anyone finds the answer, please do reply in the chat. Is my Am I audible and my presentation visible?
Yes, sir, it's visible and audible.
Okay, okay, okay. Some people are commenting. That's why it's fine. I'll just try to solve 2 minutes. Let's take 2 minutes to solve. I'll just put up the question once again. It's a basic maths problem with some of the concepts. So yeah, you can just start posting the answers, or else I'll go for the solution. Yes, solar can be directly used for charging with a few, of course, with the help of power electronic converters, but it can be used for charging. Uh, yes, no answers. Anyone? Just write yes, no. If your intuition is working, just write yes or no. Okay. Um, so the answer, if we solve it, it comes down to yes, and the household will not be without power, because 90% of SOC is around this value, and a 8.2 ampere discharge, as I have told here. That will mean that this will last for 6 hours and 22 minutes. So it comes down to 6.36, which is around 22 minutes, 21.6 or something. So the operation will, the power fails at 12:07, so it will last till 6 and 29. So if we assume that instantaneously when the sun rises at 6:25, it gives power to the PVs. So that, with that assumption, we can say that it won't be without power. Um, a second part of the question will be a little bit later on the PVs and all. That I haven't solved here. That's up to you to solve and let me know. Uh, so Now, getting back to charging stations and supplies and level 1, 2 charging. And so chargers can be broadly classified into level 1, 2, 3 and extra fast charging. And these are typical values at which the level 1, 2, 3 and extra fast charging work, which is around 1.5. This is completely for household. Just you come in, as you plug your mobile phone, you just plug in the chargers for charging your EV. This is let's say for your apartment buildings, they will have this type of charges, 7 kilowatt apartments, or your college campuses. These type of it's a mostly public charges. You can have it in your house if you want, but these are mostly public charges. Level 3 is mostly extra ultra fast charging capabilities it has, and this Tesla V2 charging station notably has a 120 kilowatt. And coming to extra fast charging, these are very specific to a particular electric vehicle. It requires certain communications and certain protection circuits. So that's why this is specific to Tesla V3. they have put up an extra fast charging station in the US. So this is around a power range of 150 to 400 kilowatts. Um, a short comparison. So this is, as I was telling, this is how the plugs of your level 1 chargers would look like. This for Indian plugs, it would be a little bit different, but it looks like a direct power supply charges. So these both work at 230 volts, but this has a higher current rating, this charger, rather than this. And also the power will be more, and it gives for a 6.6 watt, it needs a onboard charger, as I was telling in the, it needs a onboard charging uh, uh, power electronics to charge. So that 6.6 kilowatt, it gives so a 7 kilowatt chargers should be fed to a 6.6 kilowatt onboard charger. So coming down to the charge time, it charges around 7 to 30 hours depending on the battery charge. Here it is reduced to 4 to 5 hours. So a household might have, or an apartment building. So this is mostly for overnight charging. Uh, and these are benefits for e-bikes, scooters, electric wheelchairs, where the battery power, the available battery powers are, the battery ratings are low. And a driving charge, which is calculated as meter per minute, will have around 130 here, and this is quite high compared to this. This is around 670 meter per minute of charge. Now, this will be, these are quite well when it comes down to the power demand. It requires 1.5 kilowatt, that's fine. To give you an idea, a normal household will use around this much per day. So that's fine. It is within our household limits. So this is 10 kilowatts if my handwriting is not that good here. So but coming down to level 3 and extra fast charging, which looks like this is a particular Tesla V3 charging. These are also level 2 charging, and this is how the charging port looks like. I have a few slides on the charging ports as well, the CHAdeMO and the CCS charging. So that's coming later. Uh, okay, comparing these now. These again, this is a DC. This is also a DC charge. This has ultra fast capability, but these ultra fast capability is a trade-off when it comes to the state of health of the battery. Battery degradation is high. Um, these are quite costly to set up, the extra fast charging, and which is very interesting is this part, which is the power demand, as I was telling. This works within the limit of a household daily power, but these two works at almost 5 to 16 household daily power demands. So that's quite high. But it comes with its benefit. It charges around 80%. This is also a little bit more than 80%. Sorry, the time taken is less. So depending upon the battery, it charges. So these are very useful for, let's say, a petrol pump or a restaurant or a takeaway place where you just get in, take 30 minutes to buy groceries or something, and just your EV would be charged. So these are very good for those kind of situations. Now the driving range, this is very high. It's almost 37 kilometers. This is good for highways where it's assumed that there are not many EV charging stations. So this is very useful for that kind of scenarios. So all the charging stations, all the charging type of levels of charging has some benefits, but it comes with some trade-offs as well. So as I was telling, this only works with specialized EVs with protection circuits. And another thing, just post the questions if you have in the chat. I'll go through that because the time is very less. So I'll just take the questions at the end of the 45 minutes where we'll start the Q&A session. That's why not checking the chat window right now. So just put in your questions. Charger ports, there are a few other charging ports as well, but these are the most commonly and widely accepted chargers, which are the CHAdeMOs and the CCS. One is first produced in Japan, and another one is in the US by Society of Autonomous Engineers, SAE. Um, this is my CHAdeMO and this is my CCS. It, uh, So this is an upgrade of level 2 into a level 3 fast charging. So introducing of two DC pins. So what it does, this benefits has is a 2-level AC and a 2-level DC. So a CCS charger can charge the EV battery at 4 levels. So whatever level is required or whatever level the user wants it to charge, it can charge it. So this freedom is quite useful for various uh, time of applications. So this one is mostly accepted by globally by BMWs, Mercedes-Benz, Ford, and General Motors. However, on this side, Nissan, Mitsubishi, Subaru, and Toyota have supported this type of chargers. Although this charger is slightly getting obsolete due to the lack of acceptance, but still, these were the first people to start with a fast charging port. And a noteworthy point, Chevrolet was the first one to come up with a charger EV. Uh, okay. Coming to Indian standard, Indian standards are slightly changing right now, but government regulation is a GB by T type of charger. This is a GB by T type of charger for EVs. It has one AC level and three DC level charging, but uh, people will eventually move into a global accepted chargers like CCS probably, but right now these are the standards when it comes to EV. EESL is the organization which installs these charging stations. These are this organization is responsible for all the charging ports, the standardizations, and everything. And one of the mandatory requirement in Indian standard charging is the cable theft protection and physical locking system. This is important as mandated by EESL. You can find a whole detailed report and in their website, EESL. If you just Google it, there is a whole report about the standardization. If you are looking to make a charger station, or you need to follow all those guidelines, so just go through that if you're interested. If you have a project in mind or something. It is called, the standard is called Bharat DC001. For So these all about whereabout chargers and charging stations, charging ports, levels of charging. Now, a few of the technologies that we have given in the brochure. One of the most researched topic is the vehicle to grid, and the next one is the second life of EV, because there is a huge uh, like let's say talk about the where do we recycle the batteries of EV, because that will produce waste, and that the whole point of EVs is to reduce the to have a sustainable development. That's why the second life of EV is quite important. Uh, Coming to vehicle to grid, essentially all battery BEV is the battery electric vehicle short form. BEV is always viewed as load by the utility grid. Uh, as we can see that the numbers are quite increasing for EVs, cars, and also bikes. Bikes have increased a lot. Uh, Although it is estimated to have by 2030 these number of two-wheelers which are EVs and this number of cars which are EV. So it saw an increase due to various government rules and regulations and benefits. It has saw an increase of almost this much from 2008 to 18. So this might be a beneficial to the user is that it can buy power from the charge. That's mandatory to run a EV, but it can also sell power. That's the main benefit of a bidirectional power transfer is that it can sell power to the grid when it is profitable to the owner. And most of the bidirectional power transfer and the technology depends upon the profitability of the owner. It highly markets on that because otherwise why will you want to sell your power, like there is no point. So that's the thing.
Excuse me, sir. So someone has muted you.
I'm not sure who. So this I was audible in this slide, right? If I'm
Yes, sir,
not-
it was audible.
okay. Yes, sir. So what I was telling was the vehicle to grid requisites. Uh, so firstly, we should be concerned about the enough SOC on the vehicle. If it is below, let's say 80 or 70%, there is no point. If the person wants to commute where he needs that much of charge, there is no point doing this. And this is the concern of many people who are looking for vehicle. It shouldn't portray the idea of stealing power from the user, or else they will not buy electric vehicles. So this is mandatory ethics, like you say. Uh, Government, UK government notably has started some of the free parking tax exemptions and government grants up to 10,000 for their first EVs. So that has increased the vehicles quite high, and so vehicle to grid is quite viable in these type of places. India will start to have influx of EV sales. So that time probably India will also think about that. So strong communication between the grid, the vehicle, and the vehicle owner. This is very important so that there is no point in their mind of stealing. And the right of the owner should have all the rights to instruct or initiate the charging. If he wants, he can ask the EV to start a V2G charging, or else it should be the complete ownership and complete right of the owner itself. So if we look at a flow chart, so the EV owner instructs for the vehicle to grid charging. Now EV will have read the SOC of it currently and the required SOC. This can be done with data from the previous journeys. It can have a uh, algorithm to understand the estimate the next journey, and it will determine how much it can sell and how long. It can also, if you want, you can add another layer that how profitable will it be if we sell at this point of time. It can communicate the data to the grid via a smart meter at the charging point. Smart metering is not something new. It is done with on-grid PVs as well, photovoltaics systems. People use smart meters or bidirectional meter to sell power to the grid. Now, selling power to the grid, one thing to be noted is it's not that easy to sell power to the grid. It should have a lot of uh, synchronicity with the grid. The voltage, the power, everything should be synchronized, or else it will have a very adverse effects on the grid. If you just directly try to input power from any source we want, that would be uh, very harmful to the grid itself. So that's when we say communication is important, it is essential and very important to have a synchronicity with the grid while we are trying to sell power to the grid. So the grid will communicate back with per kilowatt pricing to the EV, saying that if you want, you can get this pricing, and and it should have the right to initiate and stopping. Once it gives the enable from the if we look at a subsystem or enable system, if we this is, let's say, the EV owner, it gives the enable value. Now this will start working, and here the stopping and starting will be controlled by the grid. Um, should have a high level of secured EV owner data, because people can track. If it is not highly secure, people can track their EVs data of where it goes and how much time it. So that's a lot of security breaches that can happen. So that is important as well. Advantages and disadvantages. It is quite complicated to understand and make a system which works with complete synchronicity with the grid. That's major research area where this is being done to make it as synchronous as possible. But advantages, it can be transformed into a distributed load balancing device. It can produce power at peak load hours, where it can, if it is plugged into here, it can produce peak power when it is needed. Emergency standalone power source during load shedding or power cuts. These are impossible to overlook um, when, especially like a solar PV is used to charge this. So this is a potential power plant happening, and it has, this is the source battery. So if it can send power back to the grid, that would be like a power plant, in-house power plant, or a captive power plant, if you say. So just to give you an understanding of why this is so much of interest, if a household requirement is around 10 kilowatt hour per day, uh, so it can give you an annual consumption, let's say annual consumption, depending upon the annual consumption of 3650, it can vary. So it can give you a power about 2 to 8 days power, depending on how much of the battery pack is there. And it can charge when it is at off peak. So tariffs for power system at off peak are cheaper than at peak demand for saving. So it can trade powers. That's the main reason V2G is such a great uh, research interest of. Okay. So as I was telling, this is the second part. So of the question. So at after 6:25 a.m., the house and the vehicle is powered from the photovoltaic solar array. EV, the owner of the EV needs to go at work at 8:30. So, and it needs at least 20% of the SOC to complete the journey. So, what will be the maximum? What will be the maximum SOC of the EV battery if the owner makes it to work? So, again, I'll wait for 2 minutes, and then you can just write down the question, the values. This is not solved in the next slide, so you can solve it and let me know at the end of the session. In the meantime, I'll try to answer a few questions. Yes, cyber attacks. That's what I was telling when I'm talking about secured communications. Current scenario of electric vehicles, it's quite good. We are going towards the right direction in when it comes to EVs. Uh, they have a lot of incentives. Many states have given uh, incentives, tax rebates, tax exemptions for EVs and EV owners. So that's these incentives will help them to change because although EVs will be globally nationally accepted once the prices of the EV comes down, because the main question with people is why is EV so costly and why should we go for EV when we can afford a, a better car of, let's say, IC engine at that price. So that's the main thing. And Tata is working on that extensively to come to make the prices of EVs at par with their normal conventional vehicles. So that's the main issue with. Okay. Not much left. I'll go through. So the second life, another way to restore our grid and restore the batteries to make it most useful, because the main issue or the main motivation behind the second life of EV batteries is that manufacturers or the OEMs will say 80% of SOH means you need to change your battery, and even Nissan companies like Nissan will provide incentives if you bring their batteries back to them at 80%. Now, what they do with this battery is used at a different way, which is a second life, where there is no need of so much of, let's say, Nissan Leaf will have around 24, 26 kilowatt hours, and these will also have around 90, 68. So it's around 90 kilowatt hours or 100 right now in the new model. So 80% is not feasible for EVs, but it can be used for other, uh, like a source to uh, feed household demand, power demands. So that's the main essential uh, idea behind the second life of EV batteries. So this makes it three sources. We can have three sources or more renewable sources if you are. Uh, we can have wind also, but that's not that much profitable, I think. So, anyways, so there are now three sources. Now we can permute and compute to make a deterministic energy savings algorithm of on peak and on off peak and on peak tariffs, so that we the owner can have a maximum savings in their electricity bill. So what are the various scenarios is peak looping, event discharge, and PV and batteries? There can be many other scenarios. So just a quick look into the peak looping profiles. Um, what it essentially means that the power from the grid is at a threshold. They have determined the threshold because on peak hours are from this like 8 to 11 in the 8 in the morning to 11 at night. So they have given a threshold about how much power they will take, because that's when the power is most costly, and the rest of the power demand is met with PVs and batteries. So that's the idea behind the peak looping. Now it has restricted the power from the mains, and then after the off on peak there is on off peak from 12 to 7. So there it takes in power from a lot of power from the main supply, and it charges the battery for the next day. See, the SOC of the battery slightly reduces and then goes up. This is where the battery charging happens for the uh, second life of EV. But this is not that much profitable, to be honest, because it has a payback time of around 30 years of the analysis. This is the paper if you want to refer. So this is around a 36% cost savings. Although this is quite well, but it has a payback time of 30 years and requires a battery replacement as 16 years. So that's not profitable, but this is a scenario we can work with. It's not super profitable. It is profitable because we are saving 36% of your energy in normal, and the capital cost is around quite high. So that's around almost 5 lakhs, or more than 5 lakhs in Indian rupees. Uh, Another one can be done is an even discharge profile, where the battery has been restricted to a constant discharge rate. Battery cannot discharge more than a constant rate as given. So that gives a better payback, and a third payback time is less, has a greater savings, because we are trying to keep the battery as healthy as possible, not to over discharge. Because here, if the battery, if the grid, if the power demand is quite high, the battery will give all the power. So it has no control over the battery discharging or the depth of discharge. There is, if you are familiar with batteries, there is a depth of discharge. So depth of discharge should be as less to keep the battery as healthy as possible. So the savings and the payback is quite reduced, but still it has a not that profitable. The next, which is proposed, is using batteries and photovoltaics. As someone asked, can solar power be used to charge the batteries? And we can charge, and also we can use algorithm to use battery packs and PVs together to reduce our grid dependency on our power. So that's quite interesting. This is a graph by my professor on battery management system, his paper. So he has done an experiment at location Sheffield. So here we can see there is quite interesting that here the power is taken from the solar. Most of the power in here is not taken from the battery, it's only taken from the solar. And the solar instead and the battery, instead of getting discharged in other profiles, here all the batteries are getting discharged. But here the photovoltaics or the solar charges the battery for later use when the sun is not there. So that's an interesting thing where we can charge the battery unless here we are discharging. Here, instead of this, we are charging the battery here. And here, when it's night, there is no use of photovoltaics. We are just using battery power uh, to supply our power demand. That increases quite a lot. It's 75% of cost savings, and it 14 years of payback, and the battery replacement time is around 16 years. So before your replacement of battery, you can have a payback, complete payback on your investment. So um, PVs has a priority based here, priority based. One is to meet the energy requirement first, then to supply the charge to the battery energy storage system, and then to supply the grid with tariff prices so that it can, if you have excess power, and when the power by the solar is generated low, so the battery will provide the required power. Um, Power electronics for battery EV charging systems. There are a lot of uh, topologies on battery bidirectional EV charging system. I have referenced a few papers at the end. So essentially what it does is it has a, so if I can explain here, so it has a control system which determines when the power should be moving from the grid to the battery, or when it is moving from the battery to the grid. So that's essentially is controlled by these power electronic devices. If you are interested in that, let me know. We'll arrange a separate only to discuss the power electronics if you are interested. But so the basic idea is this. So again, this is one type of topology. This is another which uses high frequency transformers. These are quite lightweight when it compared to low frequency transformers or 50 hertz transformers. So the core materials are quite low and all those things. So that's why this is quite lightweight for bidirectional chargers, because onboard charging requires you to have an onboard transformer inside the onboard charging. So if the weight of the transformer is quite high, that decreases the power efficiency of the electric vehicle in general. So that's why we use high frequency transformers. So this part is my AC to DC, and this part becomes my DC to DC. So this is DC. This is also a DC to DC converter. So that essentially, so DC to AC, and then again AC to DC converter. And this is my AC to DC. So this is my AC to DC. Um, Again, one other thing I'll just touch into is a range anxiety. You must have heard of that, people who are interested in EVs. So it defines, Wikipedia defines it as the electric vehicle has insufficient charge to reach the destination. That's the main idea behind it. So these are the few ways we can mitigate range anxiety, and one of the approach is vehicle to vehicle charging. It has extenders. Government of India is quite promoting this battery swapping technology, which is very interesting, and it's very useful for us as well. So that's one way to mitigate range anxiety. Vehicle to vehicle charging essentially means you can have an emergency vehicle just to put in the charge, just like a fuel, it just put in the charge here, or you can have two vehicles giving charge to each other. uh, you can look into this paper if you are interested in that. And it can take place in highways, parking lots, school campus. You just put in the charging and forget about it, and it will give you necessary charges.
Excuse
So
me, sir.
yes, yes,
Sir, it's about 45 minutes
yes, yes,
and
yes.
we have
I'll just,
left
I'll
only
just,
50 minutes. Okay, sir.
okay, I'll just finish it. I'll have two slides. That's it.
Okay, sir.
Okay. So the interesting part is we don't have to have any other bidirectional topologies, because we can just make use of this part here. So this is essentially this is also providing the DC, this is also providing DC. So if instead of a grid, we just provide a car here, that would work just fine. So that's the interesting part, where we can just use that vehicle to grid and all those charging techniques into this. Concluding, charging infrastructure, all depending upon the supply usage and the driving range. These depends the type of charging infrastructure we need. Vehicle to grid charging, a way to use BEVs as a power source rather than a load. And also the second life of EV batteries is the various scenarios explored with EV. Uh, as I told, the peak looping and the event discharge profiles. Sorry, so new researches on mitigating range anxiety is a very interesting topic. If anyone is working on MTech projects or BTech projects, you can work on that if you're interested. So that's about it. And I'll just put up this slide and I'll start taking questions if you have, so that people can just, if you're interested in these references, anything related to battery, just go into this website. It has an extensive type of uh, articles on batteries, battery chemistries, battery technologies, and everything. And just one thing, I have few webinars also on electric vehicle modelings with MATLAB Simulink. If you are interested in that type of thing, you're trying to model electric vehicles for your projects. We have a 5-day webinar coming up, and also we have battery technology courses if you're interested in that. So just go on to our website and just search through it. Thank you, and I'll take questions. Okay. Yes, HVDCs are getting okay. Dipansh Sati. I'm not sure I have taken a EVs. So, replaced by gasoline, what effects will it have on grid? Of course, the load will be increased. So that's why we need some technologies to give to make the, or else we are just consuming power. We are just consuming more and more electric power. And electric power right now is mostly made with non-renewable sources. So that's not helping our environment at all. It might be, but it's not. Ultimately, the cumulative effect is the same. So we need to first change our uh, gradually changed into renewable sources of energy to provide the main source of power. Like um, I think UK and also Netherlands have done that. They have not used any non-renewable sources for a year, I think. Netherlands probably has done that. They have all renewable sources. That's a great way to sustainable development. Uh, what is the current scenario of electric vehicles in India and in future? I have answered that. It's quite good. All the incentives the governments, the state governments are giving, that will certainly have a good effect. Cyber attacks, yes, the communication, the secured communication is needed when we are trying to uh, put power into the grid. There is two parts. One is the synchronicity with the grid, and another one is the communication part with the grid. So both are essentially both are equally important for that. HVDC charging, yes, people once it starts getting a traction, like EV starts growing up, uh, government of India will start to do this HVDC. Tesla, the future, that's debatable. I'm not sure what you mean by that. Uh, Even I'm a fan of Teslas, but they use induction motors, so that's not good. Induction motors aside, it's getting phased out by permanent magnet motors. It has its benefits, but anyways. Um, HVDCs propose microgrids. Yes, that's a good way to research microgrids. Um, EV charging structure infrastructure can be disturbed if hydrogen fuel cells. Hydrogen fuel cells. There are few cars coming up with hydrogen fuel cells. Hydrogen fuel cells are a little bit different than EVs, although the basic powertrain and everything is same. But these have different charging and all those things. So I'm not sure how to answer this. Um, but it's a long way to go before we get a complete hydrogen fuel cell uh, toppling the EV industry or the battery electric vehicle industries. Um, how power demand curve will be maintained if more chargers are integrated with the grid? Um, that's an interesting question. It can be maintained. We have a quite a robust. India has one of the best robust power grid right now, uh, and it can handle a lot of uh, loads and all those things. But again, as I told, we can make use of the vehicle to grids and all those things, vehicle to vehicle charging even, so that there is also renewable source charging, ultra capacitor charging. We can have ultra capacitors as well. So uh, that's the way we need to have some sort of other resources, not only depending on the grid to provide our battery electric vehicle charge. Fuel cell, a better option to be replaced by from batteries of, see, in theory it is, because batteries are made up of lot of uh, elements which are bad for the environment. So in theory it is, but in practice, this, although this started quite long back, but this has taken a front seat right now when it comes to the development in the technologies. These have to catch up. So, uh, okay, can we have any reference book on or research papers of power electronics used for EV onlys? Um, you can have a book. There is a book called Electric and Hybrid Vehicle Technologies. You can search it. Um, not sure who is the author. I forgot about the author. Uh, okay, I'll just drop a mail with the mail that invited me to the lecture. I'll just drop the mail with the books and the reference papers. Okay. Um, what are the disadvantages of bidirectional converters? Disadvantages, if you want, one is there are a lot of like PFC, power factor control, and all those things you need to understand. There are disadvantages because power electronics, it looks easy to control. You're just opening and closing switches, but the uh, control system of that is quite like it's very difficult uh, because it's not easy to always synchronize the uh, power with the grid, the supplying power with the grid. See, the direction towards the battery as a load is fine because that's what chargers do. But the opposite direction when it comes to supplying the grid, because grid is supplying to the whole, let's say, a part of our country, not the whole country. So that's quite serious. You need to consider a lot of issues when it comes to that direction of power transfer. Will you share this PPT? Yes, I think people are recording the session, so you can get that. If you still need the PPTs, let us know. I'll try to share that. Um, what are the scenarios who wants to make career in EV charging infrastructure? So you can go in two ways. One is the job. You can find there are many companies coming up on EV charging stations like Voltec and all another company. Many companies based out of Delhi, Bangalore, they are coming out of that. So you can go for that. You need to have a strong knowledge on power electronics and the charging standards that needs to be followed. Uh, Also, grid integration is quite important. Like there are IEEE regulations, IEEE standards which needs to follow for any source to be put into the grid. Um, Fresher having interest in power electronics. Yes, of course. If you have done power electronics in your BTech, I'm assuming you have done it, or your masters. So that's all you need. So it's all the same. Power electronics is so it's all switches, and so the control of the power electronic where it becomes interesting, and you can device controls. If you are trying to do research, you can do on that. Um, how many more? Uh, is this vehicle produce the same power and torque as manual transmission fuel vehicle? Okay, the torque speed characteristics of EVs are a little bit different. It has a higher starting torque. Um, I can draw. So to answer your question, if this is my speed, this is my torque. Um, Conventional vehicles will have a torque speed characteristic something around along this. I'm not perfectly drawing that, but what I want to talk about is the torque speed characteristics of EVs look something along the line of this. So the starting torque is quite high. You can get a higher starting torque. Now we can also control the torque speed characteristics using controllers, motor controllers, field weakening. If you have heard about field weakening, maximum torque per ampere, these things can be used to control our torque speed characteristics. Um, yes, of course, fast charging will affect the overall life of the battery. So that's the trade-off with fast charging. Like, but you need to understand what kind of like, let's say uh, you are in a highway or you need the fast charging. So that's the decisions that we have to make. Um, can I use higher capacity batteries while battery replacement? See, higher capacity means it will need more space. Um, so so if you can fit that battery into your, I'm not sure you can, because every battery comes at different shape and size depending on the vehicle. So I'm not sure you can do that while you're replacing the battery. Which type of battery, which type of lithium ion is mostly used? There are a lot of lithium ion battery chemistries which are used. Lithium titanate, lithium iron, Li, lithium iron phosphate, lithium manganese. Uh, there are a lot of lithium ion chemistries which are used, and but lithium titanate has an interesting characteristics when it comes to lithium ion battery. That's a little bit different and has a lot of energy. The power density is quite high. Uh, Sorry, I took 8 minutes or something more, 5 minutes more, I guess. So I think I have answered most of the questions. If you have any more questions, write us to Subrajit. You can forward the questions. Can we store an emergency backup for the vehicle like a secondary battery? So rather than storing a secondary battery, what we do is we have range extenders, we can have ultra capacitors, those kind of thing, or we can use a hybrid electric vehicles where we can use our IC engine to charge the battery. So because again batteries take up the maximum weight, if we do a analysis of battery of the weight of the vehicle, the maximum weight of the vehicle comes down to the battery. So if you have a secondary battery, that will take again that much of weight, and weight will reduce your efficiency of the motor. So that's the trade-off when it comes to secondary battery. Uh, Um, okay. Uh, Hybrid engine, hybrid electric vehicles will have parallel configuration, series configuration, depending upon what kind of. So Toyota Prius is if you take Toyota Prius, um, that uses permanent magnet motor, electric motors. because we studied Toyota Prius motors while I was doing my masters. So that uses permanent magnet. Nissan Leaf uses permanent magnet. So mostly, apart from Tesla, mostly will use permanent magnet motors, or um, e-bikes will use BLDC motors. Teslas use induction motors for some reasons. Like there are benefits with induction motors as well, uh, but mostly European manufacturers, Japanese manufacturers will use permanent magnet PMSM motors. Uh,
Excuse me, sir.
yes.
There was a quiz said before, right?
Yes. The quiz will be sent after this session. We will send the PDF for the quiz. Okay.
So,
And
sir, how would we fill it?
that's a MCQ quiz, so you just fill it the answers and we'll check. So that
Oh, it's a
okay.
Google form.
Yes.
Okay.
Yes. Okay. And you can also answer. I'll leave a space for the questions that I asked today. You can answer that on a space. Just write answer to the question in the presentation. Just fill it. So okay, and not much questions left. So I have answered most of the questions. So thank you, and I hope I have. It's a very short webinar, so I tried as much as I can to put in. So I hope you have learned something, or you have taken ideas from that. So thank you.
Okay, sir. I would like to thank Mr. Antrap Giri for accepting the invitation. In fact, we are privileged to have you as the speaker. Last but not the least, I thank all the participants on behalf of IEEE Student Branch SB of Jyoti Engineering College. I kindly request all of the participants to leave the chat room.
So I'll leave the meeting, and good night and stay safe.